Good morning. Welcome to another session of services in high-rise buildings. Today, we will look at a very basic form or a very basic requirement of air conditioning, basically air distribution. Before we get on to air distribution, let us examine what one knows about air. Air, in its very prosaic form, is the central requirement of air conditioning. Without air, there would not be any air conditioning. What does this air do? It picks up the heat from an air conditioned space and moves it out. So without air, there would not be any air conditioning at all. Let's examine what is air. To a physics student, air is very simply a mixture of oxygen and nitrogen. In percentage, one might say it is 4 parts of nitrogen and 1 part of oxygen. 80%, 20%. Now, the most important characteristic of air is that it's highly elastic in nature. Elastic in the sense that if one had a room full of air and he were able to compress it, he could perhaps put it into a small tube which is like a toothpaste tube. So just imagine the kind of elasticity we are looking at. Where is it that this air is present? Can you see it? Obviously not, but it is there all over. It is an extremely vital component of living and life. Why? It's basically not because of the 4 parts of nitrogen, it is basically because of the oxygen. Now, oxygen is basically the life-giving component of the air. Even a fish underwater needs the oxygen. It derives the oxygen from the water. Whereas you and I are not underwater at any portion of our time. We are all in air, but we derive our oxygen content from the air, which is what most of the living media, whether it's a tree, whether it's a small animal or a big animal, draws its oxygen requirement from. What does this air contain? It's basically supposed to be a mixture with oxygen, but by virtue of its elasticity, it gets invaded by a lot of parameters which are, you might say, not wanted. What are these parameters? Let's take a look at a small list of these. The most commonly ones are heat, water vapor, any other vapor which might be in an industrial ambient, of course cold, which is the opposite of heat, dirt, odor, items like pollen, dust. Now these unfortunately tend to get into air by virtue of air being elastic. So how does one keep out these components? The first way of keeping out these impurities out of air is by enclosing the air that we need to control. In other words, the basic requirement of air conditioning is basically an enclosure. The enclosure has to be tough enough, good enough to keep out the pollutants that we saw earlier, heat, RH, pollens. So in other words, when you address all these parameters, one can put together a form of enclosure that would try to keep out all those pollutants. For instance, to keep out heat, one would need an enclosure which has good insulation. To keep out moisture, one would need an enclosure which has a good vapor barrier. So like this, the moment you identify that you have to treat air in an air-conditioned room and you are going to be worried about the nature of pollutants that are likely to come into this room, you will build an enclosure which is apt enough to keep out or minimize the invasion of this air by these pollutants, as one would call them. Now, the moment you identify that you have an enclosure, you can do various things to the air which you have in this enclosure. You can add heat, you can remove heat, you can add moisture, you can remove moisture, you can clean it with filters, you can distribute the air through fans, through ducts. You may even do any single one of those things, or you may do all of these collectively. Given that air needs temperature control would be a very large subject in its own right. It would encompass the whole of air conditioning. We will not look at it in this session largely. We will confine ourselves to basically just the requirements of cleaning the air. Temperature and RH we would leave out of this session saying that it's another session by itself, or maybe a couple of sessions by itself. But other smaller aspects like cleaning air, like controlling the other smaller aspects of it, will be dealt with, and then we will get on to the more serious issue of distributing the air. Why does one need cleanliness in air? It is basically to effect proper health and hygiene. A hospital needs clean air so that it can control the invasion of bacteria and virus. Bacteria and virus, as one knows, are limbless creatures. They travel only on dust. So in other words, infection is something which moves on dust, and since you cannot catch a bacteria or a virus, you catch the dust, you have controlled your bacteria and virus invasion. So filtration is something which is what contributes to the proper cleanliness of air. Now, what are the kinds of basic locations of filters that one can look at? You can look at filters to be incorporated on an air conditioning device. This I would show as an air conditioning device. You could have a filter which can be mounted on the discharge end of a device, or it could be mounted on the suction end of a device. That means this is the air conditioned space. From the air conditioned space, you draw out return air. It goes back into the cooling device, and you could have a filter before it enters the machine, or you could have a filter after it is cooled by the machine. This kind of a device is called a blow-through filter, and this is called a draw-through filter. As you can see, the nomenclature is extremely forthright. It's on the drawing end of the machine, it's called a draw-through filter, and this is a blow-through filter. Now, these filters are the ones that are responsible for keeping this room dust-free from airborne contamination. What are the kind of filters that one can have? One can have filters which are dry, filters which are viscous, filters which are electronic, filters which are chemical, filters which are carbon type filters, or even filters which are submicronic and which are capable of filtering extremely fine dust. These filters we will see one at a time. The dry filter is basically a filter which uses dry media. If one spreads a piece of cloth in the path of air, obviously there will be some filtration. If one puts a single thread in the path of air, there will be some filtration. The difference between the two would be that a thread will catch only a particle which impinges on the thread directly, whereas a cloth will have more number of threads, and it will have a better impingement from the dust. So in other words, between a thread and a cloth spread across an air opening, the difference is basically an efficiency. Both a single thread or a piece of cloth might be classified as a dry viscous filter. A dry filter. Now, if the same filter needs to have a slightly higher efficiency, one can coat it with an oil, one can coat it with some media, and then this is called a viscous filter. In other words, you have basically an improvement in efficiency and slightly greater holding capacity. The moment you put an oil on a dry media, its capacity to be able to hold on to the dust it has picked up is better. All these filters, whether it is dry or whether it's a viscous filter, are best used at velocities of about 350 fpm or roughly 2 mps with a static pressure loss of a quarter inch of water gauge. Now, these dry filters, which you see in most of the air conditioning equipment, are just simple panel type filters. Some chemical industries, some continuous processes will not allow you to use a panel filter which requires to be cleaned from time to time. In such cases, a dry filter can be used into a self-cleaning device, whereby you see small devices of these filters are put together and kept in the path of air, and these themselves keep rotating. They rotate and a part of them goes into a cleaning fluid, maybe an oil, maybe a water, and these filters keep moving down, pick up dust, and they go through a water receptacle. At that point, they deposit all the dust and they go back as clean filters to come in a recyclable element. Now, these are called auto roll filters. These are generally affordable for continuous processes, but basically they are filters. They only allow zero downtime and they allow continuous usage. Now, apart from these dry and viscous filters, one can look at electronic filters. These electronic filters use power, use electricity. They charge multiple wires across an air opening to very high voltages with the help of capacitors, and this high voltage is used to collect dust. It is like, these small tricks that we used to play as children. You used to take an ebonite pen, rub it on your hair, develop static electricity and pick up a small bit of dust from the table. That static electricity which was generated on a pen end by rubbing against the hair would amount to a few volts which was accumulated on the tip of the pen. Now here, instead of keeping on rubbing media, what one does is he charges electrodes, he charges wires across an air opening by this kind of power, which is developed generally by capacitors, and at a high voltage these are ready to pick up dust which moves across them. So these are called electronic filters. These are also used very popularly and have a limited use in the sense that because they consume power and are prone to people getting accidents, they have not become very popular, like the dry and the viscous filters. The electronic filter works also best at the same parameters at 350 feet per minute, and they also develop generally the same static pressures like what you see in the earlier filters. There are other filters like the chemical filters and the carbon filters. The chemical filters are basically sprays of chemicals. If one has a certain pollutant which is identified in an industry, for instance a rubber industry uses a lot of ammonia. Now ammonia has been liberated in an atmosphere. How do you control it? You allow this air to pass through a spray of a chemical which will absorb the ammonia. So these are chemical filters, and these are generally specifically used for specific pollutants like in industry. Carbon filters are used for controlling odors. These are used in comfort air conditioning. One might say, let us say you build a bomb shelter underground where you have a lot of people crowded together, but to dilute the pollutant from these people you would normally require fresh air. But just imagine being a few hundred feet below earth, keeping yourself in a bomb-proof shelter and liberating pollutants from a personal body. At that point of time, one reduces the quantity of fresh air required and tries to control odor by using carbon filters. These carbon filters are expensive, they can be regenerated, but they have limited usage for these kind of applications where it's expensive to take fresh air to dilute the pollution. Generally, the answer to any pollution is dilution. So in a cinema theater, for instance, we are very sure that there are 1,000 people sitting inside. You have a lot of pollution from these people in the sense that, perspiration, odor coming out. There, very simply, nobody uses carbon filters. People just increase the quantity of fresh air so that the pollution of each person is diluted by the addition of fresh air. It is cheaper and more controllable and a nice way to do things. But supposing you have a situation where you can't take a large quantity of fresh air for limitations like, let us say, the shelter being underground, or like the air conditioned area being in a place where you cannot draw a lot of fresh air, then you necessarily need to control odor by these kind of special filters which are called carbon filters. Better than these carbon filters, one has absolute filters. These filters are the same dry filters. They have a very, very high efficiency. Their efficiency is as good as 99.97 to 0.3 dust. Now 0.3 dust has been selected as a standard media because that is the dust which you get from dope, dioctyl thiolate. Thiolate is spelled with P, not T. So dioctyl thiolate, when it is burnt, generates smoke at this level, and this is used to standardize your filter. If a filter has 99.97% efficiency to this dust, 0.3 micron dust, one might safely say that you can catch hold of literally a large percent of the dust which one would encounter. in any normal atmosphere. These filters are extremely popular in places like operation theaters, where you have patient wounds being exposed. Let us say you look at a neurosurgery OR. In a neurosurgery OR, a patient's head can be opened for as much as a few hours. And during those few hours when it is opened for surgical operations, it has every chance of dust getting into it, and this dust would be loaded with bacteria and virus. So the best form of control is to filter the entire air which is used in an OR with absolute filters to ensure that airborne contamination is absolutely under control and basically minimized. You never can reduce it to zero, but you can minimize it to a lot. This would ensure that basically dust is not there, and if dust is not there, you are very certain that bacteria and virus will not find a way in. So it's an indirect control on sterility imposed by good filtration. These filters are better run at slightly lower velocities than the other filters. These can operate at 250 feet per minute as opposed to 350 feet per minute for the other, but the major change comes where the pressure loss is as high as 25 mm as opposed to maybe 6 to 8 mm of the earlier filters. Those filters never went beyond quarter inch, that is 6 mm. These filters go to practically 1 inch, 25 mm. Now the impact of these high pressure losses on filters is that the older systems would operate at very low static pressure, which means the fans were very small, whereas if the air conditioner has got to be fitted with a HEPA filter, one needs a more powerful fan which will work at maybe very high pressures of nothing less than 60, maybe even highly 100 mm. Another use for HEPA filters is also obviously when you use them for safety purposes in nuclear establishments, because in nuclear establishments also it is basically dust which is normally sought to be controlled. Let us say if one is looking at a reactor where you are trying to control the nuclear emissions, it would be wrong to say that nuclear emissions get onto dust, but any component which picks up this kind of radiation is likely to be a potential hazard. So invariably one finds HEPA filters being used for nuclear medicine, for nuclear research, and for any place where nuclear fuels are handled in the open or in an enclosed state also. Now this much for the nature of air. Let's get on to the basic requirement where we started off. It is basically to look at the distribution of air. Now knowing that we have controlled it, you have kept out the heat, made it cold, you have kept out the high humidity, made it acceptable, cleaned it up. Now what do you do with this air? You have to distribute it. We are looking at a place which is large. You have air available at a point. We normally call this point the air handling unit. The air handling unit has cooled air which is required in the AC space with the help of the air conditioning machine, the cooling media. So in the air handling unit, you have a heat transfer between the cooling media and air. There in the air handling unit, you have got air available. How do you distribute this air into the space where it is required? Obviously, generally it is required only for the comfort of people. In other words, schematically, one is looking at a device whereby you are trying to have a big fan, a large fan, cooling a large space with maybe small enclosures like this. In these small enclosures, how do you distribute air? How do you distribute air to get into every enclosure? The devices that one can use are basically sidewall grills or ceiling diffusers. The sidewall grills, basically as the name implies, are fitted in the wall, and the ceiling diffusers, obviously as the name implies, are devices which are fixed in the ceiling. The simple characteristic of a sidewall grill is that it can throw air, you might say uninterruptedly, for as large as 50 to 70 feet. Please note the caution on uninterruptedly. That means if you have a sidewall grill, it can throw air absolutely, very clearly, very simply for 50 to 70 feet or 15 meters to 25 meters, but it must be uninterrupted. If there are banners, if there are beams in the way, obviously the air will not be allowed to travel its entire length and it will get diverted by the projection it has in. So as long as the flow from air is the flow of air is uninterrupted, it will travel its length without any nuisance value. What is the requirement of a sidewall grill? Obviously you require a vertical fascia. In a vertical fascia, if this grill is mounted, it affects this. You normally see these grills very commonly used in most of the auditoriums, most of the cinema theaters, particularly the ones which are retrofitted. You find lobbies on both the sides, you find corridors on both the sides. One puts a false ceiling, put a duct in those corridors, and immediately you have a place for locating a grill and discharging the air from the side. Now the sidewall grills can be discrete or they can be continuous. A discrete grill is something which is meant to discharge only supply air. If it is a continuous grill, the discrete portion remains behind the grill discharging the supply, and the balance area is used for collecting the return air. This is how it would look. Schematically, the grill must be mounted at minimum 8 feet and it can discharge about 15 meters without any problem, or even higher. Now, why is it that this has got to be at 8 feet minimum? This is because the air which is discharged from the grill is very cold. It is not supposed to hit an occupant directly. So in very simple parlance, you discharge air into the unoccupied area. It looks like a paradox. You effect air conditioning for the people here, but you discharge the cold air into the unoccupied area, because what you're discharging is very cold air and you do not want it to hit an occupant. The moment it hits an occupant, he would be uncomfortable. Can you think of an example where this is not avoided, where you cannot avoid hitting an occupant with a supply air grill? Yes, all of us are aware of it. A simple car, when you sit in a car, can you avoid feeling uncomfortable if you happen to occupy the driver or the seat next to him? No, because the supply air grill in the dashboard tends to hit you. And to make yourself comfortable, you try to tone down the temperature, you try to deflect the grill, but by no device can you meet this requirement which we saw earlier. You are not able to discharge air in a car air conditioner in the unoccupied area, because there is no such thing like an unoccupied area in a car. Maybe just a few inches above your head is the unoccupied area, and you can't discharge air like a laser into that space. So basically, in the car air conditioner, you can learn one device that if cold air is discharged in the occupied area, you tend to feel uncomfortable. Why? Because you have no unoccupied zone in a car. But in an air conditioned space where you are designing the space, you will discharge air into the unoccupied area, create an induction in the occupied area because of the high velocity overhead, and create comfort. Right. Let's look at the next device. Before I go on to the next device, there is one small aside on a grill. The grill devices discharges air by a phenomenon you might call a jet. Air is jetted out. You get a jet of air. So in other words, a grill operates like a jet. A ceiling diffuser, on the other hand, is mounted in the false ceiling or a ceiling, and it generally is said to have a radius of diffusion equal to mounting height. In the earlier grill, we said it just throws. So there was a new term. That means it just throws forward. It doesn't do anything else. It can only throw forward. Whereas a ceiling diffuser, it diffuses air down, and you have a new term. A radius of diffusion is equal to its mounting height. Here, basically, you have a device which is fitted into a ceiling. It can be used for supply. It can be used for return air. But its discharge will always be parallel to the ceiling, and its radius of diffusion. That is, if you use the diffuser as a center and draw a circle, the radius of diffusion will be equal to its mounting height. Now, ceiling diffusers are much better than sidewall grills because they throw air parallel to the ceiling. Because they throw air parallel to the ceiling, the air is obviously automatically discharged into the unoccupied area, which means the person feels less draft. Going back to the same example of a car, the requirement is automatically met. You have the air quantity being spread into a large space, and ceiling diffusers become absolutely necessary in places where the discharge air quantity, this is a small parameter which is very common to an air conditioning specialist, where the air quantity exceeds 2 CFM per square foot or 20 meter cube per square meter. One automatically has to use ceiling diffusers because the sidewall grill will become too drafty. Unlike the sidewall grill, which was discharging air by a jet device, these devices, the phenomena by which the diffuser diffuses air is called the Coanda effect, and the ceiling diffusers can be discrete like the sidewall grills, or they again can be continuous. A continuous one is generally called a linear diffuser because it's all in one line, and a discrete one is called a square or a circular diffuser. You must have seen these very commonly in most of the auditoriums or restaurants that you visit. A sidewall linear diffuser generally discharges air parallel to the ceiling, as I said. Obviously, straight away it is higher than the person who's in the occupied area, and you can notice that it hugs the ceiling and goes. So this is what is called the Coanda effect, unlike the sidewall, which creates a jet and generally creates a drafty. Whether it is the ceiling grill or whether it is the diffuser, most of the air outlets discharge air at 500 feet per minute. That is roughly 2.5 meters per second. That is why, this is too rapid a thing to be discharged into the space. So invariably what happens is this air is discharged into the unoccupied area, and you get an induction which is generally 1/10 of this, because by Newton's law, the moment you have a moment, there's an opposite reaction. The moment you have a moment of 2.5 meters per second velocity, 500 feet per minute, moving at a higher area above the occupied zone, obviously there is a sympathetic air movement in the occupied zone, which generally one might say is about 1/10. So if you move air overhead at about 2.5 meters per second, in the occupied zone you get movement at 0.25 meters per second, which means 25 feet per minute. So it is just the right motion to give you a feeling of comfort. The motion of this small velocity will be so small that will not even get a paper to flutter, but it's intrinsically required to ensure that the pollution from a person gets wafted away, gets carried into the return air, and ensures this feeling of comfort. So that is why you notice when comfort is defined, you not only get a parameter of 24 degrees, you not only get a parameter of 55% RH, but side by side you get that the velocity should be 25 feet per minute. So for ensuring such low velocities, you discharge air at a higher velocity in the unoccupied zone so that you get an induction in the occupied zone of 0.25 meters per second. Thank you.